Okay, swap. Okay, next step. Go. What's happening right here? So right here, we're just invoking this function on the scope. That's it. Now we're on this highlighted line. Okay, let's swap in between each step moving instead of twice. So we're just going to go to the next step, and then someone else is going to, the other person in the group is going to answer. So what was happening there? We were simply invoking the services get me a unicorn function to go into the service. Now we're right here. Someone else who is not just talking, now explain to your group what's happening here. Okay, so we are making a defer object using $Q. What is the role of the defer object? The brain. The brain for handling something that needs to happen later. The coordinator between all the later pieces. The people that are doing the later and the people that want to know about the later. Okay, next step, go. Because Mongo has asynchronous built in. Yep. Okay. So we are invoking $timeout. We're doing something that needs to happen later. And we're just using $timeout, which is Angular's version of set timeout. You did set timeout before, so it should be at least somewhat familiar to you. Okay. And we're waiting 4 seconds. So later, 4 seconds later, exactly. This line, go. Okay, so we're using our deferred object, or our later brain, the brain that's handling things happen later, and giving back a promise. A promise is just a structure that's been formalized and established for telling people that things happen later. So we're using the brain and saying, brain, you made a promise. I'm going to pass that along to whoever asked for the unicorn. We don't have one now. So we take the brain's promise, so the brain knows all the people involved. Which goes to the next step back in the controller. Did you want to ask a question before we get back?
Yeah. In your timeout function, what does the .resolve do exactly?
When we jump into that step, I'll answer that question. We're going to walk through the whole thing, including that piece.
I thought we'd done it when we went to the timeout.
Nope, that's important to note. We did not do this resolve yet. It's inside the timeout. It hasn't happened. It won't happen until 4 seconds have passed. Good clarification. Great. So right here, what's happening in the controller? Go. All right. So all we're doing right here is we are getting the results of get me a unicorn, which is a what? A promise. We returned a promise. So we're getting the results of that and doing a dot then to say, hey, promise, when your deferred brain says you're done, here's a function to call with the results. That's all we're doing right there. We're setting ourselves up as listening. But we're listening to this promise that is part of this deferred brain. They're connected. They know all about each other. They're BFFs. Next step, we're done. That's setup. We started a request to get something, but we were told we don't have it now. So we gave back a promise, and we listened for that promise so we can be told when it's done. That's all we've done is setup. So we push the button, and we wait. 4 seconds have passed. Now the resolve line of code gets called. Describe to each other what's happening here. Okay. So we're taking our deferred object, our deferred brain, and saying, hey, I can resolve the original request. I have the answer. And here it is. Unicorns don't exist. So I found a stuffed cat to distract my 6-year-old.
Did it work?
Huh? No. It did for you? Resolve means the promise is now successful. It's now done. We're ending the promise. Oh, man. See, this is why it doesn't work. She thinks like my 6-year-old. I think the gender thing might be coming into play. Like, disappointment, Dad. Come on.
If you hadn't set a timeout on that, would have been resolve first or promise first? What would have happened if there was no timeout?
We're going to get into that in the next example. Yeah, you guys are all over the segues. So, we're resolving. It's telling the deferred brain, we're done. We have an answer. And Catherine is totally correct in saying, well, isn't this incorrect? Aren't we? That's our code, though. We get all the power. We do what we want, right? My code, my rules. I don't want to feel like a failure of a dad, so I'm calling it a victory. Right? So, but in the real world, if someone asks you for something and you don't at all get it, maybe it's a resolve, maybe it's a reject. It depends on how essential it was, right? If they're like sending me search parameters and I go look in the database and I don't find anything, I'm still going to resolve it even though I found nothing because they smashed their face on the keyboard and nothing matched, right? It's still a successful query. It didn't break, right? So reject is usually used when something went wrong, right? The file system freaked out. The query didn't happen at all. It didn't finish, right? They were saying, oh, I really need to find this thing. You're like, it doesn't all exist. I wasn't able. That was step 1 of a 5-step process, and I expected step 1 to work, and it didn't. So now I'm going to reject it because I wasn't even able to do all the steps. That's usually more how reject is used semantically to say, I couldn't finish the process. Does that make sense? Yeah. Here we're faking the go look for it by waiting 4 seconds and pretending, right? I walked through a door in another room and I stood there thinking, how long can I stand here keeping her? Oh, hey, here's a cat. And I walked back out, like I didn't found it, but I found this. Here, let's go, I'll chase you, and then she forgets. No. We're going to go on to other real examples. I'm using this one because it's really simple and focuses on the promise parts of the code, the syntax. The rest of this lecture, all I have is prepared examples coming from real use cases where I had to use promises. Right? Because the syntax, there's not a ton. So the question then is why and when, which is hopefully what the rest of this lecture is targeted towards answering. Yep. The first function you give it is listening for resolve to be called. The second function you give it is listening for reject to be called. Nope. Nope. If I was not successful on some parts, I'd reject. I couldn't finish the process. Right? Doesn't matter if I got through step 5 of 10, that's 5 steps I didn't do because something went wrong. And then that lets because really your end game goal here is to go do something asynchronous, let the UI keep working, but then come back and tell the user, yay! Which means if you say nothing, people assume success, right? So you need to definitely say not success so you can tell the user not success, right? This is about user experience. Is one of the main reasons this kind of stuff exists. Okay, so we resolve that. It goes to the brain, which then takes it and says, hey, anybody listen to that promise I had? Anyone do a .then on a promise anywhere? And the answer is yes, our controller did. Our controller did a .then on the promise that got returned from the brain. Yeah, you can chain them. We're going to get into that too. It's just a parameter name. I called it unicorn because I asked for a unicorn. Yes. Yep. You can call. Yep. It's just a variable name. It's a parameter. This is a function being used in the callback style. So we're saying here's a function. You invoke it and pass in the data that I'm going to need, and that's what the brain does. The brain goes, hey, here's my value. We're done. I have a value. Hey, you gave me a function to call. So I'm going to call it, and I'm going to take the value that was given to me from the resolve, and I'm going to invoke your function and send the value in. And it goes in there, and then we get it, and we put it on the scope, and then we see it. Okay? So, this example, even if you replace this with like an HTTP, that's already giving you a promise. You don't need to make a promise when just doing a basic $HTTP call. It's good practice though, and it's not a terrible idea. So, next example. I need to put some things back in. Okay. So what we're going to do is we're going to hit the Pokemon API to ask for a Pokemon. And we're just going to show this giant vomit of data on the screen. We're not going to do anything pretty with it. We're not worried about pretty today. We're worried about promises and flow. So I need to be able to push the button. It says loading. And I probably have a bug somewhere that I didn't finish putting back in. And eventually it should resolve and give me Bulbasaur and show him on the screen. So I'm going to click Get Pokemon, which is going to take me into the controller's Get Pokemon function. I set scope.pokemon equal to loading. And then I call the Pokemon service. I know what I skipped. That guy right there. Loading. There's probably something else. So nope, there it goes. It just took a while. So it took like 10 seconds for them to give me the data, which is a good thing I didn't lock the UI waiting for it. It's a good thing we have asynchronous programming and promises. Where whole screen would have gone gray and the user would have just been like, nope, this site's trash, and gone.
With the 4 seconds that you're waiting on the stuffed animal thing, would that delay the get the Bulbasaur button?
It shouldn't, no. Because that happens when I hit this button right there. So we ask it for a Pokemon, and then when we get it back, we put it on the scope. So let's go look at our Pokemon service. I'm using both $HTTP and $Q. I'm only using Pokemon because it's real. It's an actual service. This is happening live. This is not faked in any way. Right? To answer the question, do you usually fake it? No. We're doing something real. But the real use case this came from is when I was working at one of my second job, our product was huge. And there was over 280 different configuration settings users could set up. 280. It was ridiculous how many little things they could change going through the settings. The thing is you would change those like once or twice a year. When something finally annoys you enough, you want it to work different, or in the initial setup. And then you would never change them. Like if I was in the app, if a user was in the app, the odds of them changing their configuration settings were almost none. And it ended up being a call that took like a second and a half. And you guys are like, well, what's the big deal? We had like 80 calls to get up and going. So a second and a half call times 80, really big deal. So we didn't want to have to keep on going and getting it. So the goal was, user logs in, we go get it from the server because we have to. But then we keep it, and we don't go get it again unless they specifically go in and change something. Then we delete what we have and go get it again. So I needed to get it, keep it, and then say, if I have it, give them what I have already. Don't go ask the server for it. If I don't have it, now go ask the server. Does that make sense? So that's the flow that I've coded here in the service for getting a Pokemon instead of a config file. But you could swap this out for anything where you say, no, this is never going to change, and it could be expensive. Get it one time, keep it, and otherwise don't go worry about it. A really common use case for this pattern is users. I will do this pattern for users as well. Because once the user's logged in, is it ever going to change to another user? No, unless they hit the logout button. So we'll get the user one time, and then if my client needs to know, wait, who's the current logged in user? Is this their stuff? Do we care? I'm just asking a service, and it's instant. I don't have to go to a server. It's faster. So I set up a Poke Center Pokemon, because we're going to keep this in our Poke Center. Then here's my get Pokemon function. It sets up our defer, and it returns our promise. Same steps. It's what happens in the middle that's a little bit different. I say simply, if I already have a PokeCenter Pokemon, resolve. If I don't have one, make an HTTP call, take that promise, and take its promise, the HTTP promise, from here. Two promises going on here. The one we made and the one $HTTP made. Take the one from HTTP, and when it's done, resolve my promise with the Pokemon, and then take that Pokemon and put it on my variable. Should actually probably swap those two. Take the data, put it on my variable, and then resolve it. Just say we're done. So let's walk through this flow in the debugger so you can see what's happening step by step. Okay, we push the button. We say scope.Pokemon is equal to loading. Why? Just so the user knows we're doing something. When you do asynchronous programming, it's really common to have something that you turn on and off as they're waiting. ng-show, ng-hide. You know how to do that. We're going to go ask for the Pokemon. It's going to give us back a promise. Let's defer. Do we have a Pokemon Center Pokemon? No. So, come in here, make an HTTP GET call to the Poke API, get its promise, tell it when your Pokemon API, when you're done, I need the results, and then return our promise. We have two promises. We're going promiseception here. Step out, we listen for our promise, the promise we made to be done, because that's the one that we returned. We didn't return the HTTP promise, we returned our defer promise. We listen, now we wait. Pokemon API is done. It came back with the data. It gave us our Pokemon. Look at the data. We've got two abilities, one form, ID of one, name Bulbasaur, species. Way more things than you probably wanted to know about Pokemon. Or maybe not enough things. I don't judge. Huh? Do it. So, we take that and we put it on our PokeCenter Pokemon var that lives outside the function. So we have closure, data sharing, persistence. We keep it. We send it, and now our PokeCenter Pokemon is Bulbasaur. We resolve our promise that we made custom. Now, we go to the controller, it gets put on the controller, and we see it. Missed one final breakpoint here. What happens if we push the button again? Set scope.Pokemon to loading. Ask for a Pokemon. Set up our defer. Do we have a Pokemon? Yes. So resolve immediately. Before we've even returned the promise. We resolve right now. Then we return the promise. The controller listens, and then it jumps right inside and resolves it instantly for you. So you can resolve or reject a promise before anybody even listens or cares. And then the second anyone says they care, it's like, no, I already got the results. I'm going to call it right now for you. So, this is a cleaner pattern. Let me show you why. Let me show you the alternative code. So, if I don't give out a promise, and I just say, oh, if I have a Pokemon, return the Pokemon. Okay? Let's say I didn't make my own promise. I just use HTTP. You're either going to get a Pokemon or a promise. That is one of the worst patterns in code, to have two potentially completely different answers. Because how, right here, Pokemon, it's a promise or Pokemon. I don't know which. If what? How do you know whether it's a promise or a Pokemon? Huh? How do you write that in code? You can't. So you can guess, you can hope, right? I could be like, okay, if promise or Pokemon has property species, it's probably a Pokemon. Right? Because my promise doesn't have a property species, but am I sure? Could someone go add a species of promises? Or could, more realistically, could I get Pokemon data that omitted species for some reason? Yeah. So that's completely unreliable and weird and hard to handle. Because how do I know when I have a promise, and how do I know when I have a Pokemon? I don't. So that's why it's a much cleaner pattern to make our own promise, so the controller has one path to truth. .then, answer in the callback, that's where I get my Pokemon. You always give me a promise, and this is where I always get my Pokemon. And there is no other way for me to get that. Single path of truth, so much cleaner code. Let the guy who is worrying about promise or Pokemon deal with promise or Pokemon, and just give me what I want when I want it in a clean, easy, 100% codable pattern. Do you see why that's better? So now we've got the ability to have our controllers really cleanly get a promise and get the answer they want in that same order every time. And now we can do something more complex by saying sometimes synchronous, sometimes asynchronous. But the controller, one flow. So much easier to maintain. It's worth the extra code in the service to write your own promise and do this. Cool? Okay, let's take a break before we come back and we'll do a bit more. Caffeine. Caffeine will take a minute. Should we play musical chairs for a couple minutes while we wait for the caffeine? If only we had time. JavaScript, HTML, CSS, Node, and Mongo. C#, Java, JavaScript, SQL, and Python. Yeah. A little bit of Ruby, conversational in Ruby, not fluent. Huh? What?
I mean, there's different SQL versions, right?
Yeah.
How different are they? Are they pretty like similar?
95% overlap. Yeah. Yeah. Not a programming language. All right, so this next example is a little contrived, but this takes place when you want to go get data from multiple sources at the same time. Do you really want to tell the controller 3 different times stuff's come back and it's got to like wait for all of them anyway? No. Controllers should do as little work as possible. So we handle anything complex in the service. So this is our introvert scheduling service. For those that are not familiar with introverts, we have bubbles. So if you want to go hang out with an introvert, they're probably going to check the weather. If it's bad weather, it's probably not worth the effort to leave the house. They're also going to check how long it's been since their last social function. If it was yesterday, sorry, they're probably staying home. Lastly, they're going to check how far they have to travel. Travel time in a car, it's just time away from home, on top of the reason that I'm leaving. So to really hang out with an introvert, they're going to check all 3 things, and only if all of those things align, yes, are they probably going to tell you yes. Please don't take it personally if you're not an introvert, but you have an introvert friend, right? It's not our fault that hanging out with people drains our batteries, and we need time to recharge. So, that's it. I'm doing an HTTP call to some totally made-up web URLs. None of these web URLs in here are real and work. They're completely contrived. Much like many introverts' excuses, yes. Fortunately, with most of my friends, I'm comfortable enough telling them, I just need an introvert day today, guys, I'm sorry. And they get what that means, and they don't take it personal. Usually when I do that, though, I try to go out of my way a few days later to schedule something myself to show that I wasn't just blowing them off and that I still care. And I do like hanging out with them. So anyway, all right, so we're going to check the weather. We're going to check how long. We're going to check that. Each one is a promise. Each one is its own HTTP. And we're going to fire them all off at the exact same time. Let's go check the distance, check how long, and check the weather. Boom, boom, boom. Why wait? Let's say each one takes 3 seconds. If I do them one at a time, how long does that take? 9 seconds. If I can do them all at the same time, how long does that take? Which is better? This is the web, so faster is always better. Always. I don't say always or never very often. If I say always or never, that's pretty authoritative. So, the part that makes this work is this function, check all good. Each one of these, when their data comes back, invokes check all good. We're going to say check if we're all good. The other thing that we have is for each thing we need to check, we have 2 variables. One to track, are we done? Is it warm enough? Warm done. Is it warm? Or do we know if it's warm? Not, what is the value of warm? Just, are we done checking it? Are we done checking the date? And are we done checking the distance to travel? Then we have another variable that tracks the actual .data. Here's my actual distance. Here's my actual date. Here's my actual warm. So I have 2 variables for each. So I come in here. Let's say this one fires first. It comes back. It says date. Oh, it's been a week. Date done? True. Check all good. Jumps in here. Is warm done? Nope, we haven't got the answer back from warm. We're done. Do nothing. Wait. Oh, hey, warm came back. Warm's done. Check if we're good. Is warm done? Yep, warm's done. Is date done? Yep. Date's done. That was the first one that came back. Is distance done? Nope. So skip out. Don't go in the if statement. Do nothing. Do nothing. End. Distance comes back. These 2 get set. And now warm is done. Date is done. Distance is done. Now we can say, if it's warm and the date's been long enough and the distance isn't too far, let's resolve. Yeah, let's hang out. Otherwise, if any of those were false, let's reject. Sorry. No thanks.
So everything's just nested inside of each other to continue running.
Unfortunately, this one's not real. If one of you wants to go write an introvert scheduling API to hit, I will totally make it real. So, let's do this. This is a single function. I'm going to share it here in Slack. I'm going to take the code, copy it out to some place that you can edit it, and we are going to say that distance came back in 3 seconds, the date came back in 2 seconds, and the weather came back in 4 seconds. I want you to go through and annotate the code that I gave you with the order in which things are called. So just go ahead and put a number in a comment. This is called first, 1. //2, //3. Go through and just number all the parts of the code in the order that they're called. And I'll give each of you a few minutes to think through that and do that.
What were the times on those gets again?
Right there in the comment. Oh, nope, I unplugged it. I'll plug it back in. I'm a workaholic. I have a hard time going longer than 20 seconds without doing something. If you're feeling completely stuck and overwhelmed, slide over and pair up with your neighbor. I'd rather this be productive than solo. If it's hard, but you're making progress, keep going. That's growth.
Right now, we're not actually changing anything, right? We just want to figure out the order.
Yeah, like this should be answer number 1 right here. We call these functions. Then go through and find, well, what happens next? And number them. That's all you're doing. Just go through and number what's happening in what order. Let's do a thumb check on this. Up if you think you're done. Sideways if you feel like you're making progress and you just want more time. All right, 2 more minutes. Then we're going to go through it as a class, because I have one more example I want to show before the mini project. Okay. So, your numbers might not match mine perfectly, because I might decide to be a little more picky or less picky than you were. But the general flow, hopefully, was pretty close. So, the next thing I would label, because I think it's important, is the return. To understand, we're invoking those functions, they're firing, and we're leaving. Goes into each one of these functions, starts the HTTP, and is gone. So maybe it's more appropriate to say these are all step 2, and then we leave as step 3. We're done with the function, went back to the controller. We're just waiting now. Okay. Next, let's see. Date was 2 seconds. So it comes into date, and this is 4, which ends up calling check all good. So we come in here as 5, but we simply return. We don't do anything. Next was distance. So here's distance. This was 6, next in order. And then it comes in here as 7, but we're still not done, so we leave. Because not all of the variables are true yet, because we're still waiting on one. So 6, 7, last one is this one, was 8. So now we come in here as 9, and we continue forward. So this is actually 10 now. And then one of these is 11, depending on our results. Okay, there it is with my numbering. You can kind of compare it with yourself and have that as a reference. Okay. Last example. This is not one I expect you to go deep on, but it's one to be aware of so that you can think about it later when you become more comfortable with promises and your own promises. But it's one that I do think you should be aware of at least. And that is the idea of promise chaining. So I have this function called do factorial. You give it a starting num, and this function called handle factorial, and no, I would never actually solve factorials this way. This is far more messy than it needs to be. So we say we're going to do a factorial starting at 5, and each one of these chains a promise to take the result of this one, which is 5, brain fart. This is going to be 4. Is factorial multiplier? It is, right? So this is going to be 20. So it's going to take 20, and it's going to pass 20 into this call. Comments will break it. So it passes 20 in there, and it gets out 20 times 3, 60. So then it takes 60 and passes 60 in here and gets out 120. Then it passes in 120 and gets out 120. So with chaining and promises, like I said, don't feel like you need to super understand this. Just be like, wait. So you're telling me I can do multiple asynchronous things and get the result of one and pass it into the next one and then get its result and keep passing the results along the chain? Yes, you can. Yeah, that's all I really want you to get out of this. I do feel like it's an intermediate to advanced application of promises, and so I think it's more realistic to guide you to understanding the fundamentals that we've gone over better before worrying about having to understand this. So that's why it's kind of quick and fast and we didn't go deep, because I don't want you to stress it. Okay, let's do the mini project. User profiles trace. Okay, let's do a thumb check. There's just kind of one giant step. Still quite a few sideways. We'll give you a few more minutes.